let's get into some slope. Slope, or blank, the rate of change, is the vertical change divided by the horizontal change. So we could say rate of change some people like to think of it as the rise over run. It's basically how steep a line is. So the symbol in the equations we're going to have is m. The formula, you can subtract the y's in the numerator, the x's in the denominator. That'll help you find the slope. I like to think of it kind of like a table at the park. You got the legs of the table on the bottom, right? And then you got your cute little glasses sitting on top with your ice cold Pepsi or Coca-Cola. All right, so when you see a line that slopes up and to the right, that means it has a positive slope. So I always like to think as slope from left to right, just like you're reading. If it slopes down and to the right, that's going to be a negative slope. If it's a flat line, that's going to be a slope of 0. And if it is an absolute vertical line, we say that slope is undefined. So we're going to find the slope in all these various ways. It's nice if the line is graphed because then you just count your rise over run, but sometimes they just give you 2 coordinates. So you have to use this little table formula here. Find the slope between the 2 given points, -3, 0 and -1, 6. So now it does not matter which y you use first, but consistency is key. Kind of like a lot of things in math. So the formula says y2 minus y1. It just means the second y minus the first y. But you could reverse it too. Again, just be consistent. So the y's are going to be the 0 and the 6. Let's say I used the 6 first, the 0 second. So 6 minus 0. With the x's in the denominator, you would just want to use that same order. You would want to use -1 first minus -3. And if you reversed both of those, it's still going to come out to the same answer. So up top in the numerator, 6 minus 0 is 6. Denominator, I see minus negative. I'm going to go ahead and change that to plus positive. -1 plus 3 is 2. And then you just simplify this. 6 over 2 is 3. So the slope between those 2 points is 3. All right, let's try it again. We subtract the y's up in the numerator. So let's reverse the order from what we did the first time. Let's use this y first. So we'll say -3 minus -3. And then our x's will stay consistent with the order, -1 minus 5. If you see minus negative, go ahead and change it to plus positive. -3 plus 3 is 0. -1 minus 5 is -6. 0 divided by anything is 0. That's not too bad, huh? Not too bad at all, Mr. Plant. We're going to do one more, and then you're going to try one. Boop, beep. The y's go up top. Our y's are 3 and -2. We'll keep the same order for the x's. -1 minus -1. I see a couple minus negatives. We're going to change it to plus positives. 3 plus 2 is 5. -1 plus 1 is 0. If you type 5 divided by 0 in your calculator, it's going to say error, undefined. You cannot divide by 0. So when you have a 0 in the denominator, we say the slope is undefined. So try out this one. Go ahead and pause it, try it, check back in, see if you get the same thing. So the y's, we could say 1 minus -3. The x's, that same order would be -4 minus 2. Change any minus negatives to plus positive. 1 plus 3 is 4. -4 minus 2 is -6. You simplify this. Usually you would put the negative up in the numerator or out in front, but it comes out to negative 2/3. Cool. All right. What else do we got? All right, counting slope from a graph, and then we're done. Now again, slope is, you could say the change in y over the change in x. You could do the coordinate thing we just did. However, if it's graphed, there's a much easier way. You just check the rise over the run. Always go from left to right when you're doing that. You pick any 2 points. Doesn't matter which two. Let's say I pick this point and this point. So we're rising up 1, 2, 3, 4. We went up 4. We're going over 1, 2, 3, 4. 4 over 4, and then you simplify it. It simplifies to 1. That's it. Now you could take any 2 points, this point and this point. It's up 1, over 1, which also simplifies to 1. It works for all of them with linear functions like this. So if you look at this one, we pick 2 points. I see there's definitely a point here, and there's definitely a point there. From left to right, this one's going down 1, 2, 3, 4. If it's going down and right, we say it's negative, and it's going over 2. Negative 4 over 2 is negative 2. Now again, you could choose any 2 points and do that. You could choose this point and this point. It's down 2 over 1, which still gives you negative 2. Both ways, it works out. So there's one here for you to try. Pause it, try it, check back in, see if we get the same slope, and then we're done. Let's say I chose this point and this point. That's down 2, negative 2, over 1, 2, 3. Simplify it if you could, but you can't. If you chose 2 other points, you could go down 4, over 1, 2, 3, 4, 5, 6, and that still simplifies to negative 2/3. Look at us with the slope.